So what do we need if we're going to talk to a server that's sitting remote from a mobile device? So we've got our mobile device that's sitting here, and we're going to communicate between it and some cloud resources. So what do we need to do in order to support that interaction? Well, one of the most important things that we have to do is we have to select a protocol for talking to that cloud. How do we go about and talk to the cloud? And that's what a protocol is. A protocol is a set of rules dictating how we communicate with the resources on the other end of this network. Now, why do we need a protocol or some specialized way of communicating? And what does the protocol give us? So if we just go and make a local method call, this is going to be, very, very fast, nearly instantaneous. But when we go and do some communication over the network, for example, we communicate over a cellular connection to resources that are sitting in a cloud that could be, thousands of miles away. This could be milliseconds to seconds to do that communication. So there's a substantial longer period of time to establish that connection, to transfer data, and to receive some type of response that we're waiting for. So a big question that comes up is, well, how long is too long? When should I disconnect from that server and assume that my communication from my mobile device failed? Because we've all experienced it where you're driving along and suddenly your call drops because your signal goes away. Well, how does that cloud know when it's been too long since it's heard something from you? Or what if you go and log into a website? When should it decide to de-authenticate you and make you log in again? All of these things are aspects of the protocols that we design in order to communicate with some other entity that's farther away. And it's really important to have a robust protocol for this communication to ensure that we interact securely and reliably and quickly with the resources that we're trying to interact with. So to give you an example, think about the Mars rover that NASA has launched and been controlling from the Earth. When they send a message from Earth to the Mars rover to drive it or control it, it can take a substantial period of time for that message to be received on Mars by that rover. It's not milliseconds or seconds, it's on the order of hours. So think about it, you're driving this rover and suddenly it hasn't received a message in an hour. What should it do? How should it respond? Should it keep going at 50 miles an hour or 10 miles an hour or however fast the rover goes, or should it stop? Should it try to return to where it started from? So this is what a protocol defines, is it tells you how you communicate with another entity. And it defines a syntax, or basically a format for the messages that you can send to that other entity. So it says, when I send a message, it has to have these properties to it, and that's the syntax. It defines semantics, and this is basically the meaning of the messages. So if I send you message A, and then I send you message B, here's what I mean by that. I don't want you to get confused. I want you to understand the semantics of my messages, or the meaning of them. And then it spells out the timing. So if I send you message A, how long do I have before I should send you message B? Or should I even send you message B at all? Should I send you something else instead? So building and selecting the right protocol for the interaction with the cloud is one of the most important aspects of mobile to cloud interactions.